Firstly, thank you very much for having me here today. Unfortunately, I was a last-minute change to present this presentation today. My colleague Greg Wong could not be here today due to other priorities in the business, but I hope to do justice to his presentation that is prepared. A bit about Renew Energy. Renew Energy is a supplier of biogas and anaerobic digestion systems into Australia. Recently, we've also diversified into solar and PV and battery storage systems in order to come up with a full renewable energy package for our customers. So biogas, waste to energy, we're mostly dealing with anaerobic digestion, which has been spoken about previously today. We have animal manures or wastewater farm food and agribusinesses going into our anaerobic digestion process, producing biogas, and we convert that into electricity and sell behind the meter to our clients. Solar, battery, PV, in conjunction with biogas, providing a full solution for our clients on site. A bit more about Renew Energy. We've completed a number of projects across Australia, totaling about 13 projects now in biogas. We're the only company to have done biogas projects in rendering, abattoirs, pig production, layer chickens and dairies. Full service provider when it comes to anaerobic digestion. We do our own anaerobic digester design, as well as biogas handling and refining of the gas and producing electricity. Grid integration, remote monitoring, as well as operations and maintenance of the facility. With our build, own, operate model, we have able to transform the company and speed up investment in this sector with no upfront cost to our end client, where we're on their facility, we take their feedstock, we produce energy from it and sell the energy back to the client. So no capital cost to the client at the end of the day, because investment in this sector has been lacking, especially in the food and agri sector, because we're not adding to their capability or their production capability as such. So we're at the back end of their food processing facilities. But the benefits that the business actually gets is reduced energy costs for them, better sustainability credentials, and obviously reduce carbon emissions. So key sectors that we have is heating and electricity, with wastewater treatment and waste disposal. The revenue streams are from LGCs and carbon credits, and obviously there's recovered nutrients as well that can be on-sold as well. The environmental benefits are a reduction in greenhouse gases and harmful pollutants and reduced odours as well. Anaerobic digestion is a well-known technology where it's completely done in the absence of oxygen, so no odours actually are emitted from this process. We actually are reducing the odour footprint of any facility we're at. So this is a typical representation of our anaerobic, covered anaerobic lagoons. It's a very large pond, completely sealed with wastewater or effluent underneath. In the absence of oxygen, bacteria will break down all organic matter and produce methane or biogas, which has a component of methane, which we further on treat through our gas conditioning system and burn in a reciprocating generator that produces electricity. We also heat our effluent that goes in most cases to ensure that anaerobic digestion is kept at our optimum temperature. So we have waste heat coming from the generators that we put back into the digester to maintain this temperature. So the most exciting thing that we're here and to talk about for this sector for us is our Goulburn bioenergy project, which Arena is co-funding. So we will be commencing construction for this project towards the end of this month. We've sorted pretty much all the council approvals and construction certificates. So we've entered into an agreement with Arena. Arena is co-funding $2.1 million of a total build of in excess of $5 million project. So Renew Energy will own and operate this project and sell electricity behind the meter to Southern Meats at Goulburn. What the project looks like, Southern Meats at Goulburn is a sheep abattoir which kills about 4,000 sheep a day. A five-day a week operation produces about 1 million litres of wastewater a day. We take that into our covered anaerobic lagoon, which you saw a representative of that earlier. They use about 20,000 kilowatt hours a day in terms of electricity, and about 9,000 gigajoules of natural gas per month to produce steam for their facility. So the solution is we're building a covered anaerobic lagoon about 90 meters by 70 meters, about 8 meters deep. We're putting in dual fuel biogas generation systems. Why dual fuel? I'll show that to you a bit later. There is a natural gas connection that we're tapping into as well. We will be able to produce about 3 million kilowatt hours from biogas alone for the facility, which will be used during peak and shoulder periods. So why these periods? So the abattoir starts processing about 5 in the morning. That's when operations ramp up, but they're still in off-peak electricity, or if you understand the electricity or energy markets, there's peak, shoulder and off-peak. So during off-peak, the tariff is a third of what the tariff is usually in peak and shoulder periods. So during this period in red, electricity is very, very expensive for the abattoir to buy. So what we're doing is we're storing gas underneath the cover, or biogas underneath the cover, to only run generators during peak and shoulder periods when the cost of electricity is at its highest. So cost of electricity is a third compared to cost of electricity over here, so it's 3 times as much. So it makes good economic sense for us to be operating in those high electricity periods. So with biogas, we've got only a sufficient amount of biogas to produce electricity in this red columns here, in this red parts here. So with the way that they electricity demand and how much electricity they use during production, that profile actually looks like this. So this is them ramping up production, and this is when they're in their peak time of their production, and as it comes down slowly at the end of the day, and this is their profile that looks like for the entire week. So we've only got enough amount of biogas to produce electricity for these shaded parts, so we needed to supplement biogas with natural gas. As we already have the capital or the infrastructure already on site, it just made sense to supplement the biogas with a little bit of natural gas, not a whole heap amount, but just to get these green parts out of the way. So during their peak and shoulder periods throughout the entire day between 7 a.m. and 7 p.m, Southern Meats at Goulburn will not be drawing any energy from the grid whatsoever. They'll be self-sufficient with on-site generation from Monday to Friday. That's what we're hoping to achieve, and we will achieve those through the complex control system that we have on site. So we will achieve that. Will be a net positive from on-site generation. We have another egg layer production facility case study that we're sort of hoping to work towards, and this just represents what we can do when we combine renewable energies together to provide a full-blown solution to our end user clients. So this facility has 1 million egg layers, so there is wastewater available from the egg washing process. There are different daily profiles. That's what makes this project or this concept very challenging. That in winter there's a different energy usage profile compared to summer. In summer months it's a lot hotter and the birds need to remain cool, so they've got the evaporative cooling systems going at full tack and trying to control the temperature in the sheds, otherwise the hens will start dying off. So and that's the differences in the energy profile that you see compared to winter versus summer. So how can we achieve that? So there's no point producing electricity if it can't be used effectively on site behind the meter. So this is what we can generate with biogas in green during the 4 seasons. But as you can see, the energy usage on site is much higher than what we can produce. So it comes in solar and battery. So with solar and battery and biogas, we can produce a system where we're meeting more than 90% of the electricity's, the facility's electricity demand. And in some parts in winter, we're actually exporting, or we've got surplus electricity. Here in summer, we have a deficit of electricity, but in winter, we've got a surplus of amount of electricity. So those sort of things offset itself to produce the best sort of financial position for a renewable energy system for this client. Other projects that we've done in the past, just gives you a bit of a snapshot out of the 13 projects that we've done. We've done 2 piggery installations, very large ones in New South Wales. These 2 piggery facilities are actually exporting electricity into the grid as well. The poultry installation that we've already completed in 2013, we've actually upgraded the installed capacity to produce more electricity than what's on the chart, what's on the presentation. So we've just recently done that upgrade as well. And in South Australia, you would have heard that there's a fair bit of issues with energy, and we're talking to this client that we've got 2 covered anaerobic lagoons with already to convert that from being used as a gas source rather than an electricity source, to turn that over and convert that into electricity generation. And obviously the most exciting thing for us is starting this project at Goulburn at Southern Meats. So with that, I'll conclude my presentation. If there's any questions.